Hey there guys, and welcome to another video on OOP in Python 3. In this session we're going to be looking at the idea of operator overloading. So just dive right in. I'm going to show you a small example as to where this is already done for you in practice, or I should say where operators just work nicely in practice. So if I go ahead and say x is 10, let's say y is defined as 100. And if I just come in and say x is bigger than y, so of course, as you may guess, we get false because of course, in this case, 10 is not bigger than 100, so this evaluates and everything's fine, everyone's happy. Same as is equal to, false as well. Of course, we make these the same, we get true. So these work really nicely with the integer class because the functionality behind the scenes for the integer class is being set up really nicely. Of course, it's a built-in type, so you'd expect it to. Now, what if we wanted to do this same functionality with perhaps a custom class? So let's go ahead and try that and see what happens. Let's do mbAir greater than mbpro. And yeah, we get an error. It doesn't like to do it. What if I try equals to? Not an error, but we get false. But again, we don't know what exactly it's comparing. we do, I'll explain in just a second. But the idea is the functionality like more than, less than, less than or is equal to, isn't quite set up. It doesn't work the way we want it to. That's because whenever we design a custom class, if we want to make this work properly, so we want to be able to say, is this instance bigger than this instance? We need to tell it, well, what do we compare? Do we compare the model, so Air or Pro? Do we compare price, so 999 or 1999? That's what we're going to do today. We're going to look at kind of how these methods work behind the scenes and how to implement too. So what we're going to do is we're going to do more than. We'll try and keep it short and sweet. And whenever you call more than here, Python does a bit of magic behind the scenes. It goes and looks for what's called the GT or greater than dunder method. Whenever you go ahead and call is equal, it goes off and calls the EQ dunder method here. Now we can see, if I just take a second to go down here and run dir int, the directory function shows all the attributes and methods of an object. So I just quickly clear the screen and hit run. So GT and EQ, let's look for those. Let's see. Bit of a mess down here. I can sure and find them somewhere. There we go, GT. So GT is implemented here, and EQ is somewhere. There it is, EQ. There's also the others as well. So GE is greater than or equal to. There's also NE, which is not equal to as well. So these are the methods which sit behind the scenes, which actually do the heavy loading of checking, is the left operand bigger than the right operand, etc. Now, what's interesting, if I go ahead and say, show me all the attributes and methods of an instance of the MacBook class, I'll be thinking they don't exist, when actually they do. So, which is kind of surprising. It's like, well, I haven't defined them here, so why do they exist? Model and price are there, of course, I have to define those. And that's all because of what happens when you make a custom class. So back in the old days, we used to have to do this. Back in the old days, it makes me feel very old. We used to have to implement from what's called the base object class. So if I run that, it looks exactly the same, doesn't it? And that's because in newer Python 3, kind of Python 3 onwards really, this is done for you. So you actually kind of unintentionally inherit from what's called the base object class. And this base object class is where these all come from. So those are all defined in there, and they do the bare minimum. A lot of the time, well, like we saw with GT, errors out in this case. But the EQ, the way that's defined in the base object, it basically checks the identity of the two things. So if I quickly do, let's say, by identity, I mean like, are they the same object in memory? So if I say, is mbAir the same as mbAir, of course these point to the same place in memory, they have the same identity, therefore it's true. So that works fine. Of course, we don't want to compare that, so that's why we're going to overload it. And then that's why that gives false here. So what we want to do is rewrite these methods. So we're going to rewrite GT, and we're going to rewrite EQ, so that they actually do something useful. Let's start with greater than. To do that, let's get rid of this, make that this here. Now there's loads of ways you can make these methods really fancy. You can put in lots of error checking. I'm going to keep it fairly basic. I might do a try and accept. Well, I'll do a try and accept with the GT, but there's loads of ways. For example, if you wanted to compare this to another integer, You can make it really fancy and really beef these methods out. I'll try and keep it nice and simple just to show you the basics. So we're going to define def dunder gt. I call these dunder methods. A lot of people do as well. Some people call these magic methods, so call them dunder methods, magic methods, whatever you like. Choice is yours. And I'm going to build this up kind of incrementally. I'm going to say self and other. I'll come back to what these mean in just a minute. And just say return true. So recall that this previously errored out, didn't it? It gave us that type error. Now it returns true. And that's because this, of course, looking for GT, goes off and calls this. And now we've said, okay, well, don't do anything fancy, just return true. That's why this is no longer erroring, because greater than, the greater than operator is implementing this method here and actually doing something. So what happens behind the scenes whenever we do, is this bigger than this? Goes to GT, MB air is passed in as self, MB pro is passed in as other. So what we want to do is some magic here to say, let's do price, for example. Is self.price bigger than other.price? So you could do an if statement. You could do if self.price, greater than other.price, return true, else false. You're best off just doing it like this, to be honest. Just like how you can do, if I come to the terminal for a second, just like how you can do like an inline kind of conditional thing like this, free bit and 4 to get false. We can do the same thing in our class. So if I come back up to here, we can just say return self.price is bigger than other.price. This will evaluate and get back to you with a true or a false. So if you kind of envision these two being passed in here, MB air, so MB gets passed in as self, so its price is 999, is bigger than other, so other is passed in as MB pro, other's price is this guy here. So we're basically doing that. We're saying return 999 is bigger than 199, and I'll obviously evaluate it back as false, and here we go. Let's suppose the MacBook Air has the world's biggest price jump. It's true, and it works. So that is a prime example of operator overloading. We've taken the existing functionality of GT, we've overloaded it with our own functionality, and we're good to go. Just some limitations, of course, if you were to do something like this here, I might cover this in a future video, how to make these really fancy. This is still not going to work, because in this case, 500 gets passed in as other, and if you do 500.price, Python's not going to have a clue what you're talking about. So you could do perhaps maybe a fancy try and accept. So you could say try and do this, except maybe what you could do. Let's just do a blanket try and accept, and then maybe we could re-raise an error. So we could say let's do value error. So I can't compare these. So not particularly fancy, but you could do something like that if you wanted to. There you go. So perhaps something like that. What you could do potentially is look at what instances of what class these are. If the right one happens to be numerical, like an int or a float, then try and compare them. But you could do it whatever way you wanted to, really. So that's how you do a basic overloading of the GT operator. So move that off here. Up next, we're going to do the EQ one. So let's just quickly clear the screen. And it's the same game as earlier. Go ahead and make sure you're in line with your other defs. Def, EQ, self, pass in other. This doesn't have to be other, by the way. It's just convention, and I think it makes it easy to think, right? Self is the thing we're calling it on the left, so MB Air, MB Pro. Other is just the other thing we're trying to compare it against. And it's exactly the same deal. So check this out. You just copy this, put that in here, is equal. So now we're not comparing the identity of the objects, we're comparing the price attribute of the objects. There we go. Okay, and what I probably should do is maybe get rid of that. Rookie error. Try that this time. Okay, so let's see what's happened there. So that's given us an error because I've kept in price. Let's just quickly do MB Pro. So now we're actually doing something nice. And we get false. Okay, so that's given us false here because let's just pass these up. So MB Air has got as self. Self.price is 2999. MB Pro here gets passed in as other. And others.price is 1999. Okay, so therefore that's returning false because this is not the same as this. Let's suppose in some kind of weird universe these are the same. I don't know, maybe it's a top spec Air and a bottom spec Pro. I don't know, but maybe they're the same price. True, there we go. That's now true because we're saying the price of the left operand, is it the same as the price of the right operand? And if they are, like in this case, then yeah, absolutely, that's fine. You could do max up a little bit because we have this model attribute. You could say, is the model the same? So initially this is going to return as false because Air and Pro are not the same string, but perhaps you came along and did Air here like this. We get true. So just to wrap things up, let's get rid of this here. So in a nutshell, operator overloading is when you build a basic class, so your own custom class, and you're redefining the rich comparison methods like greater than, less than, equals to, not equals to, and when you're overriding them, you're basically telling them, okay, when you're comparing the left and right operands, here's what you're going to compare. So you're changing the base functionality of how those comparisons are done. So what I'll do in a future video, especially if I get some comments on this one, if you want to see these beefed up and made a bit more fancy, I can certainly do a video on those. And of course, make sure to check out the other videos in the series. And of course, if you like these videos, feel free to like and subscribe. That'll be awesome. Hope you guys have a great week, and I'll see you soon.